I think this is exercise 3.6, areas enclosed by the x-axis. So we've already spoken about area in some previous videos. If you find the integral, if you do the first derivative of a curve, and if you do the definite integral between B and A under this curve, you're actually finding the area under the curve. Okay, so the definite integral, when you substitute x values in here, gives the signed, it says the signed area under a curve. Now what it means is if you if this is y is some function of x, and if you integrate it and then you substitute in the values of b and a, you know, in the square, like if it's a definite integral with values here, if you get a positive answer, your area lies above the x-axis. And if you get a negative answer, so for example, if the function is down here and the area bounded by the curve and the function, you'll get a negative answer for your integral. So it says, so for example, if your function is here and this is the x-axis, you'll get a positive answer for the integral between b and a of that function of x dx. So it says areas above the x-axis give a positive definite integral, but areas below the x-axis give a negative definite integral. So let's say this is my function of x here, the squiggly line, and I'm substituting in my values of b and a. If I do the area, if I integrate function of x and substitute in the values of b and a, I'm going to get a negative answer. Do you know why? Because the area is below the x-axis. So because whenever we ask you find the area, and it's always positive, so as areas are positive, to find areas below the x-axis, you have to take the absolute value of the definite integral. And we spoke about this a little bit last time when I was talking about area. Okay, so how are you going to know, but when I give you a function, whether the area is above or below the x-axis? You have to sketch the function first. And if you sketch it, you'll be able to see for these values of x, the area is above, for these values of x, the area is below. All right, now if I just ask you for the integral only, you don't have to sketch it. But if I ask you for the area, you have to know that either the area is all above, all below, some of it's above, some of it's below, and you need to know for which x values it is above or below. So we're just going to do some examples here from the exercise, all right? You've got your examples at the beginning of the exercise, and then we're just going to look at some more. So if I asked you to find the area enclosed by the curve y equals 1 minus x squared, we know that's the graph y equals negative x squared shifted up 1 unit. And I could work out by putting y is 0. I can work out where my x-intercepts are. It looks like that. If I do this integral, do you expect the answer to be positive? All right. Now, yes, I can do from 1 to -1. You know, there was another way I could have done this question. Do you think this curve is symmetrical about the y-axis? So I can do this as area is the integral between 1 and -1, and I'll just put this in brackets, of 1 minus x squared dx, okay? So that's just scribble, which is, you know, you integrate that and you get x minus x cubed on 3, and you substitute 1 and -1, and you do all that, right? But we should get a positive answer for this. Do you agree? So let's see what we got. So we substituted in our 1 and -1, and we got 1 and 1/3. So the area is 1 and 1/3 units squared. Now, this is just question 2 from the same exercise. Look at this question. Find the area bounded by this curve and the x-axis. Well, this is y equals x squared minus 9. X squared is up here, shifted down 9 units, would be down there. If you want to know where it cuts the x-axis, you have to know where it cuts the x-axis. You have to put y equals 0 and solve, and you get x is 3 and -3. In other words, we're sketching the curve. Now, when I do this area bounded by this curve and the x-axis, it's all below. Can you see? So you have to do area is the absolute value. And why do I choose 3 and -3? Because the curve binds the x-axis between the values of 3 and -3. You must put the positive value first and then the -1 underneath. Otherwise, you will get a negative answer. Now, look, we will get a negative answer. So you integrate your function. All right, you all know how to integrate. Substitute in your values, just be careful. And we'll get -36. So the area is the absolute value of -36, which is 36. All right. Now with this one, question 6, find the area enclosed by the x-axis and this curve. We know this curve's concave down. I know the y-intercept is 3, but I have to find the x-intercepts. So I'll put y equals 0 and I'll solve, and I get 3 and -1/2. But all that area is above the x-axis. Do you agree? So I don't have to break it up into pieces. I can just do the normal integral between the values of 3 and -1/2. Now, if I did not put y equal to 0 and solve, I would never know about these 3 and -1/2 values to plug in. Do you understand why it's 3? Because it's the area bounded by the curve and the x-axis. And that's bound between the values of 3 and -1/2. So yes, we integrate that, but we have to work out which values we substitute in here. And that's why we put y equals 0 and solve. So you do your integration, you substitute in your 3. Look, I substitute in my 3, put it in big square brackets, minus, substitute in the -1/2. Notice I've done every single substitution there. Work out first bracket, minus, and then work out the second bracket. And I got 14.3 units to, I think it was 1 decimal place. Now, all that area is above the y-axis, which is above the x-axis, which is fine. Now, if we look at question 9, find the area enclosed between the curve y equals x cubed, the x-axis, and the lines x equals -2 and +2. Now, so I sketch it and I get, when I put x is 2, I think I get y is 8. And when I do x is -2, I think I get y is -8. Tell me, half of the area is above and part of the area is below. Do you think that the size of this area is the same as the size of that? What do you think? You're going to get a positive value up here and a negative value down there. So if you actually did the integral between 2 and -2, what would you get? You'd get 0 because the areas are the same. So you don't do between 2 and -2. We're going to do this a long way and a quick way. Okay, so do you think the area between 2 and 0 is going to be the same as the area between 0 and -2? All right, so let's have a look. We want to find this area. Look, you can do the integral between 2 and 0. You'll get an answer. Do you think I need to also, if you're doing the integral here, you always do the higher value minus the lower one. Should I bother doing the integral from 0 to -2? What answer? I'm going to get the same answer as this, but as a negative. So look, just watch. I'm going to say, right, I've got 2 areas here. I'm going to call this one area 1, and I'm going to call this one underneath area 2. Okay, now let's have a look. Area 1 is the integral. Sorry about this, I had absolute value signs there, but you don't need them for the first bit because it's above the x-axis. Area 1 up here is the integral between 2 and 0. You integrate and you get 4 units when you substitute. If I did decide to do the integral from 0 to -2, you must do 0 and then -2, the higher value first and then the lower one. I get -4, which is to be expected. Do you understand why it's -4? So did I really need to do it? I didn't. So instead of, but because the second one is below the x-axis, I have to take the absolute value of it. And I say, well, area 2 is 4 units as well, so the total area is 8. Now, instead of doing that, we can say, well, you know what? I've noticed that x cubed is an odd function. Well, that's y equals x cubed, or function of x is x cubed. It's an odd function since function of -x equals negative function of x. That's the rule we learnt earlier in year 11. Function of -x is -x all cubed, which is -x cubed. And the negative function of x is also -x cubed, so it's an odd function. So so you can see how this area will be the same as that. Instead of doing the integral from 2 to 0 and then the absolute value of the integral from 0 to 2, why don't we just do 2 times the integral from 2 to 0? Do you get it? So instead of doing that, so therefore for odd functions, there is a shortcut. For the integral from a to -8, so it would have to be like 3 to -3, 2 to -2, 1 to -1, for example. This works because these functions have point symmetry, 180-degree symmetry about the origin. Instead of doing from a to negative a, if you do that integral, you're going to get 0. If you want area, it'll be 2 times the integral from a to 0 of the function of x dx. So in the question we just did, because we know, don't bother doing the negative one. We know that the negative area is the same as the positive. We just write area is 2 times the integral from 2 to 0 of x cubed dx. 2 times, that's the integral. Substitute in your 2 and 0, and you get 2 times 4 is 8. Now that is a lot quicker than doing them individually. Now we can also, this process also applies for even functions. So I think in 2 of the questions we did have some even functions earlier, but I've got another one down here, which is question 11. And question 11 says to find the area bounded by the curve y equals 3x squared. The x-axis and the lines x is 1. See, this is x is 1 and x is negative 1. In other words, we're trying to find this area. Do you think this is an even function? It is. It's an even function. It's an even function because function of x equals function of negative x. Our function is 3x squared. So if you substitute x in, you get 3x squared. If you replace the x with the negative x, you also get 3x squared. So function of x equals function of negative x. So it's even. So you tell me which integral I should do. From 1 to 0, always highest value first. 2 times, look, this area is the same as that. Area 1 equals area 2. So let's just do 2 times area 1. You know what? It's better. It's really good to substitute 0 into your x's because they just wipe out. You don't end up with values. So for example, this one, let's see how we can do it. We could have done, if we wanted the area, let's say the area, if you do from 1 to negative 1 and just integrate, you're going to get 0. No, you're not, actually. No, it'll be fine for this one because 1's not above and 1's not below. You would still get the correct answer from 1 to negative 1. It knows that that's above and that's above, and it will add them together. But instead of doing that, and there's nothing worse than substituting a negative sometimes, we know that area 1 and 2 are the same. So why don't we just do 2 times from 1 to 0. So that area is 2 times from 1 to 0, and you can integrate and substitute it, and you get 2 units. Now, alternatively, I could have just substituted from 1 to negative 1. It will still give you the area for this one because they're all above. It's because all the area is above the x-axis, look. You only do absolute value when part of it's below. So I could do from 1 to negative 1 because they're both above the x-axis. It's not going to cancel anything out. But if we do 1 and negative 1, you'll get the same answer. But you've got to substitute a negative, you see. But you get the same answer. All right? And I think this next question, so actually I'll just go back here for a sec. See this question? You can't do 2 times anything. It's not even. You know, if it's even, it's symmetrical about the y-axis. That's not an even function. I'll show you which one is. Do you think this is an even function? Yeah, so you could do 2 times from 1 to 0. Does this make sense? But we did from 1 to negative 1. You still get the same answer. If I show you this other one, this was the second example we did. This is an even function as well because the left-hand side of the graph is the same as the right-hand side. So I could have done 2 times, or what could I have done? But be careful. Am I going to get a negative value? How else could I do this area? It's even. I could have done area is 2 times the integral between 3 and 0. I need to take absolute values. Do you know why? Because that 3 to 0 is going to be negative. Of x squared minus 9 dx. So I could have also done that question that way. Okay, and I would have got 2 times x cubed on 3 minus 9x between the values of 3 and 0, which is 2 times, that's 27, that's 9 minus 27, got to do the absolute value, minus 0 minus 0, which is 2 times negative 16, no, negative 18, an absolute value, which is the absolute value of negative 36, which is 36 units squared. So do you get this idea about odd and even functions? Please, you must sketch the functions, otherwise you're going to have problems. Now, in this last question, so that was question 2, just did it an alternative way. In this last question here, question 19, this is done in the next video, but ladies, the thing is, you cannot integrate the area. If I ask you here, find the area bound by the curve y equals square root of 4 minus x squared, the x-axis and the y-axis in the first quadrant, I want this area. Yes, you know it's the integral between 2 and 0 of the square root of 4 minus x squared dx. The thing is, we do not have a formula for integrating this. Tell me why. Why? Why can you not integrate this? Because of the x squared. You only know how to integrate of the type x to the n or ax plus b to the power of n. That's all we know how to integrate. Not ax squared plus b to the power of n. All right, so with integrals, we only know how to do those types. The problem with this, the half is fine, but the problem is the x squared. You cannot integrate this, so I can't integrate it. I don't know any rules to integrate that. But what do you notice about this? That it's I did do one of these a few days ago. It's a semicircle, no, a quadrant. So isn't that, it's not a semicircle, it's a quadrant above the x-axis with radius 2. So what would its area be? You could approximate using Simpson's rule and that, but I wouldn't. Isn't it just a quarter of pi r squared is the area? A quarter of pi times, what's the radius? So the 2's cancel, a quarter of 4 pi units squared. You cannot integrate this, please. These are the only things you know how to integrate. What do you get when you integrate x to the n? X to the n plus 1 over n plus 1 plus c. What about this one? Ax plus b to the n plus 1 over n plus 1 times a plus c. Okay, so you can only differentiate that, not integrate. Function of a function or chain rule is only for differentiation. It is not for integration. Okay, so please, the only two things that you know how to integrate are x to the power of n and ax plus b to the power of n, not ax squared, not ax cubed, not anything else. Okay, we will learn how to integrate these types of things, but in extension 1. All right.